Guys, welcome to week 4. This is week 4's math overview. So to get us started, we're going to start off with some fluency practice. I'm going to start with our 8s chant, and then we're going to review our 3 9s tricks. So let's switch over so you can see my screen. I almost forgot what I was doing. And there it is. Okay. We're going to start here. Let me get rid of this guy. All right, you should be able to see the 8 songs. So here we go. Dukes up. JS, good as gold. Let me hear your fingers roll. I don't know what you heard about me. If you think I can't roll my H crazy, so sit down and listen carefully while I break it down for you mad slowly. It goes 8, 16, and 24, 32, 40 and 48, 56, 64, 72, 80, 88, 96, and now we're through. So that's our H chants, just to remind you. Now I'm going to switch over to our view of my whiteboard here. Let me see if so to refresh you on some names, ignore my terrible nails this week. I worked in my classroom and it tore them to pieces, and then I did some yard work yesterday morning and it's just furtherly gross. All right, so first we're going to remember the 9s counting up and down by place values. So if I started here, let me move my screen, at 0, I could go 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember, this is going to stop at the 10s. And then I can come back up and do 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is the 10s place. This is the 1s place. We're familiar with those two for place value. Draw it like that. So then what's 9 times 1? That equals 9. 9 times 2? 9 times 3, 9 times 4, 9 times 5, 9 times 6, 9 times 7, 9 times 8, 9 times 9, and then 9 times 10. Now remember, if you're using this strategy to get the times 11, you should know your 11s really well. 11 times anything is that number twice, so 11 times 9 is 99, and then you can add 9 more to 99 to get 108 for 12 times 11. So use those different strategies. So this is the first strategy for 9s. There's so many strategies for 9s. I didn't do a 9s song. So now let's remember the less than 1 and add them to 9. So when you're doing 9 times, let's say, we'll do a different number, 9 times 7. What is 1 less than 7? So 1 less is 6. Now 6 plus what equals 9? Well, if you count up 6, 7, 8, 9, we get 3. And so 9 times 7 is 63. That works for others too. Let's do 9 times 5. What's 1 less than 5? 4. 4 plus what equals 9? 5. So that's our 1 less adds to 9 trick that you can also use. Now let me switch it back over. Stop sharing my screen so you can see my fingers. Well, actually, I might do it on here. Ignore my terrible nails and my finger. I was carrying laundry and hit my knuckle on a door frame, and so now I've got a terrible Band-Aid on my finger. All right, so for the 9s trick, remember that you start, I'm going to have to zoom out to get more of my hands in here. Start on your left side and you work across. So if I'm doing 9 times 3, I start on my left hand and count over 3 fingers. 1, 2, 3. I put that finger down. And so on the left of this knuckle, I have how many fingers? 1, 2. Let me uncap. So that's my tens place. And then on the right side of my knuckle, I have 1, 2, 3, 4, 5, 6, 7 fingers. So my answer is 27. Now remember, this only works up to tens, 9 times 10, because why? You only have 10 fingers, and it would get a little awkward to try to use your toes. So let's do another one. Let's do 9 times 6. Actually, I'm going to leave this uncapped. It's easier that way. All right. So again, starting on the left, counting over 6 fingers. 1, 2, 3, 4, 5, 6. It's this thumb, so put that thumb away. So how many fingers do you have to the left of the thumb? 5. How many do you have to the right of the thumb? 4. So 9 times 6 is 54. So that's the quick refreshers on your nines tricks to help you out with your math fluency this week. All right, I'm going to leave it on this view and take you over to doing our word problems. All right, so today, oops, I dropped my eraser. Got it. All right, so this week we're working with some general measurement problems. The first several on your page of problems are standard, to where if you know how to do read, draw, write, and you use tips to help you go through the steps of working a problem, you should be good to go. Down towards the bottom, it switches over from just units of measurement to using area. So remember, area is something we talked about. This up. There we go. Length times width. Oh, that is not a width. Where in the world did I get a 4 from? Who knows? All right, length times width. That is not how you made a W. So remember, we did this hand signal. Length times the width. Length times the width. So keeping that in mind, if it's talking about a shape and it wants you to find the area, that's where it's at with you. So remember, we're going to go through tips. Think about what math you see. Identify the important information. TIP. Make a plan, and S, solve for it. So let's read our problem. Molly and Caleb both skip count square units to find the area of the same rectangle. Molly counts 3, 6, 9, 12, 15, 18, 21, 24. Caleb counts 8, 16, 24. Draw the rectangle, what the rectangle might look like, and then label the side links to find the area. So when I look at this problem, I think about a couple of math things. I right away saw the word area. I know what that is, length times the width. Then I saw the word rectangle. We've done some geometry, so you should know what the shape of a basic rectangle looks like. And then I want to pay attention to the important information of what Molly is counting by and what Caleb is counting by. Molly is skip counting by 3s. Caleb is skip counting by 8s. So, sorry, every time I start talking, I get a little froggy in my throat. There's an idiom for you if you've been missing my idioms lately. All right, so I'm going to first think about Molly. And remember that when we did area of a shape, I'm going to draw a square over here just as an example. We talked about the area is everything in the middle of a shape. So here's my area. We also talked about how an area looks very similar to this, what we did at the beginning of the year. Do you remember what that was called? Hopefully, it was called an array. So you can see that I have 1, 2, 3 boxes, 1, 2, 3 rows by 1, 2, 3 in my row, 3 columns is what we called them, by over here, I have 1, 2, 3 in my columns as well. So use those strategies you remember from the beginning of the year as you start to work out this problem. All right, so let's look back at Molly. Molly is skip counting by 3s. I like that number, and I want to start there first because it's smaller. So if I use that strategy to draw a picture showing a array that I then can turn into a rectangle, I'm going to start there. So here's Molly. She goes 3, 6, actually I want to do it this way. 3, 1, 2, 3. And then 3 more is 6. Then I have 9. 3 more is 12. 3 more is 15. 3 more is 18. 3 more after that, and I got a little crazy with that last one, is 21. And then 3 more after that is 24. So let me draw my rectangle to go around this and start putting in these groups of 3. This kind of starts to look like a what? You're right, a tape diagram. So here's where I'm at right now. I did Molly's count. So let's count again. 3, 6, 9, 12, 18. Oh wait, I skipped. Let me start over. I'm trying to watch what I'm doing and count and all those sorts of stuff. 3, 6, 9, 12, 15, 18, 21, 24. So I have all of my counts to 24. Now let's look at Caleb. He said he was counting by 8s. So can you see where there might be a set of 8 in here? Hopefully. Here is 1, 2, 3, 4, 5, 6, 7, 8. We skip counted by 3 8 times, okay? So that's where he got the 8 from. We already have our rectangle drawn, so our length times the width is the length times the width is 3 times 8. So the direction says draw what the rectangle might look like, then label the side lengths and find the area. So side length 3, other side is 8. So now we know we do 3 times 8 equals, and we're going to say 24, because if you remember both of our skip counts, here is 3s ended in 24 and skip counting by 8s ended in 24. You also could go in and individually count each dot to double check yourself and make sure that you got 24. So it says draw what the rectangle looks like, check we did that. Then label the side lengths, check we did that. And then third, find the area, check we did that. However, remember when you're writing an area, you need to put a unit. They didn't give us one, so we're going to use a U for unit, and that it's units squared, because we're talking about each one of these little squares and how much it covers in the entire shape. The area is all that's in here, and you find that by length times the width. Area is everything inside in the middle, and then to find it, you do the length times the width. Okay, remember some of those hand signals. All right, so to finish out redraw right, the area is 24 units squared with a length of 3 units and width of 8 units. It's kind of how I would write that out in word form for a complete sentence. All right, so are we clear as mud on that one? Hopefully we are. A little clearer than mud. All right, so area, length times width. It's everything that's in these inside. Hopefully this refreshes you. Now, before I go on, I want to demonstrate, could you have done this rectangle differently? Could you have done 3, 6, 9, 12, 8, 15, gosh, I can't get that one out today, 18, 21, 24, and then draw on your shape this way. And then make enough space for those. Do you still have 3 in this shape? Yes, we still have 3 here. Do you still have 8 in this shape? Yes, we still have 8 here. The length and the width changed. Remember we called this the commutative property? We have 3 times 8, turn it, is still 8 times 3. So you could have had a different looking picture that was standing tall, because remember, it was just the commutative property, the back and forth. Instead of doing 3 times 8, we did 8 times 3. So don't forget about the commutative property. All right, so your picture could have looked a little bit different. Would we have gotten the same area though? Yes, we would have. All right, let's look at problem number 2. Exit out of this one. There's this problem too. Oh, yes, okay. I don't know what I just did. All right. Okay, so still working with area on this problem. Like I said, some of the other problems towards the beginning of the week packet are just standard adding and subtracting problems that are just using units of measurement. I wanted to specifically go over this week area and refresh your mind with area. So this one also will be asking us to do something with area. All right, so the tables in a classroom measure 4 feet by 6 feet. For a larger space for students, the teacher places 2 tables side by side to create one long table. Find the area of the new rectangle, or the new longer table. Can't read today either. It's a Sunday and I'm tired. Okay, so tips. Think about what math do you see? I see measurement, I see feet, I see area in this problem. Then I see important information that the tables are 4 by 6 feet, and then she takes 2 of them and puts them together, okay, to make one long table. So, a plan. First, I'm going to start with drawing out these tables. So I have a 4 by 6 table. Well, we're going to make it look something like that. And then she takes a second table to make it longer and puts it on the end. So I'm going to do this. Okay, so there's my 2 tables. Now, it does say the word side by side. And at first I thought about drawing a picture like this, which wouldn't be completely incorrect. And I'm going to show you why I would probably still take something like this if you did it like this. But my keyword that I focused on here was longer. And when I think long, I think this way, length or long. I don't know. I was thinking long and skinny. So we'll solve it this way, and then I'll show you a second way. And you're going to notice you're going to end up with the same answers twice. So here, now this is 4 by 6, and this is 4 by 6. So it says find the area of the new longer table. You can do this a couple of ways. You can first just find the area of 4 by 6 by doing length times width. 4 times 6 is 24. And then doing it again over here. Again over here. 4 times 6 equals 24. So 4 times 6 is 24 plus the other 24, and you get Actually, this is probably the only way I would solve this to get both areas. Oh no, we could do it differently. 4 plus 4 is 8, and 2 plus 2 is 4. So we now have the area. Did they give us, oh, she did give us a unit, so technically I should have put that up here. So 24 plus 24, we have 48 feet squared. Now, you could have solved it another way, and I'm certain some of you saw this. You could have done 4, because now we've created this longer rectangle here. 4 by this whole side would be what? Well, what is 6 plus 6? Oops. 6 plus 6 is 12. So this whole side now has become 12 feet long. So you could have solved it this way. You could have done 4 times 12, and that equals 48 feet squared. Okay, so you could have done that as well. Now let's discuss this my other idea. If I have my 4 by 6 table and I put it beside the next 4 by 6 table, now I have 4 and 4 by 6 and 6. The question is, will you get the same amount of area? And the answer is going to be yes, because remember, the area is what is outside or inside of the shape. Perimeter is the outside, but we're finding area right now. So length times width, this is still 4 times 6 equals 24. This is still 4 times 6 equals 24. We're still going to add them both together, which we did right here, and got 48. Now, what would look different, however, is this problem. Instead of being 4 plus a whole side of 12, we now have a whole side of 8 times a smaller side of 6. Well, 8, 16, 24, 32, 40, 48 is that 6th one. So we got the same measurement, even though our pictures looked a little different. It kind of depends on how you read the problem. When I first read the problem and being a teacher brain, and knowing the size of my classroom, this is the one I picked, okay? As opposed to doing a 12-foot long table, that would have been a little bit of a tight fit in our room. So I picked this one. Now, to answer the question to finish, it says find the area of the new longer table. I would put that in a sentence that looks like this. The longer table's area is 48 feet squared, period. All right, so hopefully that refreshed and you could see a couple ways you did it, and both ways got us the same answer. All right, let's move right along to our last problem, number 3, numero tres, if you've been missing my random bouts of Spanish. All right, let me scooch this over just a little bit. All right, Bob and Tim, start by thinking about what math you see. I identify the important numbers, P, make a plan, and S, solve it. So Bob and Tim both have rectangle measuring 7 centimeters by 9 centimeters. Tim cuts 2 centimeters by 4 centimeter rectangle out of his. Bob cuts a 2 centimeter by 7 centimeter rectangle out of his. Tom says he has more paper left over. Bob says they have the same amount. Who is correct? Well, remember that sometimes a good tip for reading a math word problem is to read it like a story. So picture it. And then that's going to give you the hints and clues you need to find the important things. So let's picture it like a story. There's Bob and Tim. They both have a rectangle piece of paper. Tim cuts out a 2 by 4 centimeter rectangle. Then Bob, with his piece of paper, cuts out a 2 by 7 centimeter rectangle. Then they have a disagreement. Tom says he has more paper. Oh, it should be Tim. That's funny, I typoed that. Bob says he has the same amount. So we've got to figure out who's correct by doing the math. So when I see this, I automatically see 2 rectangles, and then I think of the area because it says 7 by 9. And then the next step is we've got to cut their pieces off. Tim's piece is 2 by 4, and then Bob's piece is 2 by 7. So that's the important information in here, and we're trying to find out how much is left over and see if they're the same amount. So there's going to be some comparing in there, and when I hear compare, I think what? Math operation. That's right, subtraction. When you compare two things, you're subtracting to find the difference. All right, so Bob and Tim, let's get their papers drawn. I would start with drawing the same picture for both of them. So we know that they both have the same rectangle. And I'll put a T over here for Tim or Tom if you typo with me, and B for Bob. So T and B, we'll just leave it at that. All right, both of them are 7 by 9. 7 by 9. Let's first, using our nines trick, let's find the area of these 2 rectangles because they're both going to be the same. So we just have to do it once. So I'm going to lay my fingers out here so you can see it. So since we're doing 7, I'm going to count over 7 fingers. So 1, 2, 3, 4, 5, 6, 7. Put that down. How many do I have on the right? I have 1, 2, or the left, sorry. 1, 2, 3, 4, 5, 6 on the left. And then 1, 2, 3 on the right. So my answer to the length times the width, 7 times 9, is going to equal 63. And they said centimeters, so I'm going to put centimeters squared. This is going to be the number for both of them. So I'm going to write it underneath both of their rectangles. But now remember, in our story, there's a second thing that happens. They both get some scissors out and chop off some of their rectangle. Well, let's look at Tim first. Tim does a 2 by 4 centimeters. So I'm going to go 2 by 4. So I'm going to have a 2 and a 4. Well, let's use our length times width to find the area of that piece. 2 times 4 equals, if you're like, I don't know, well, 2, 4, 6, 8. Use your skip counting. So that equaled 8 centimeters squared. Bob is over at his table, or at his seat, and he cuts off a 2 by 7. So let's make a little bit bigger cut because we have 2 by 7. So use that same length times width. 2 times 7. Well, 2, 4, 6, 8, 10, 12, 14. So Bob cuts off, there's a fly in here or something, 14 centimeters squared. Okay. But Tom is arguing he has more paper left. Bob is saying, no, 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 I have more paper left. So I'm going to go ahead and just shade this off as if they cut this whole part. So we can really see, like, that is just, it's gone. It's no longer there, okay? You could even almost just erase it off of there to show that they have a little section. They've whacked it out. It looks like a lot of piece of leftover construction paper, I find. So remember, we want to compare how much they had to begin with, taking away what they cut off, because that's the action, you cut it off. So when you take something away, that is subtraction. So we're going to set up a subtraction problem, and I kind of already have it for us. So I have 63 minus 8 for Tim, and then 63 minus 14 for good old Bob? Well, use your subtraction strategy. So 3 take away 8. Can you do that if you only have 3 things? No sirree. So you have to go next door to the 6, take away a set of 10. You're going to rename this a 5. Bring that 10 over to that 3. And now you end up with 13. 13 minus 8. If you're like, ooh, I don't know that fast fact, I've forgotten it with all my at-homeness. Well, use either a count up or a count down strategy. I like counting up. So 8, 9, 10, 11, 12, 13. I end up with 5. Then over here I have 5 minus nothing. I have another 5. So the amount of paper that Tim has left is 55 centimeters. But remember, we've got to compare that to Bob's. So over here, Bob had 63 minus 14. Well, I can't do 3 minus 14, so I have to go next door to the 6, borrow a set of 10. That now becomes called 5 or 50. Then we go back to the 3, give that set of 10, and now we rename it, and it's 13. Kind of squeezing that in there. Sorry about that. 13 minus 4. Well, depending on what strategy you like to use, if you don't know that as a fast fact, this time let's count down from 13 4 fingers. 13, 12, 11, 10, 9. So we end up with 9 when we get 4 fingers up there. Then we have 5 take away 1. And that is a fast fact you should know. And that is 4. So Bob was left with 4 centimeters squared. All right, now, have we finished the problem? Not quite yet. There was that last little bit that said, who is correct? So let's go back and reread who thought what. Tom says he has more paper left. Bob says they have the same amount. Who is correct? Well, here's Tom. Here's Bob. Do they have the same amount like Bob says? 55 compared to 49? No. If you use one of our symbols, our little Pac-Man would definitely want to eat Tom's construction paper over there. He had the greater number at 55. So, to put that in a complete sentence, not Tom, it was originally Tim, and then I changed it and didn't put a T, an I. Tim has more paper left with 55 centimeters squared. He is correct. Period. Okay, so that kind of sums up the answer to that. We followed tips. We have the read, draw, write. These types of problems are easy for the draw part because it really helps you picture this math that you're putting on the board. We wrote our math problems, we solved them all, and then we wrote our answer in a complete sentence. We followed tips. We thought about the problem and the math that it had. We looked for important information. We made a plan, and then we solved that problem. So hopefully this is a great little refresher for you for math this week, focusing on area and measurements. Like I said before, the first few problems are just using units of measurement to solve standard add, subtract, multiply, or divide two-step word problems. And then the last few gets back into area. So I wanted to remind you that area is the length times the width. My neighbor's starting to mow, of course, during my video. That's okay though. Love that he mows his yard regularly. Anyways, I hope you guys have a great rest of your week. Hopefully this was helpful to remember our length time and our width, using your 9s tricks, and then skip counting by your 8. Remember, you can also practice skip counting up and then down, and that helps you with a strategy that we used for subtraction, either counting up or down. That's kind of where that ties in at. So hope you have a great week 4. I will see you for week 5 video, and hopefully for our Zoom or our Google Hangout. And I will talk to you guys later. Bye.